dx is equals to u raised to n. The n here is the exponent. So if derived, you would have, and here at the bottom, u and n minus 1 du over dx here. So in short, we just, let's say, bring down the exponent and then, let's say, subtract it by 1. Find the dy over dx of y is equals to x cubed minus 4 x squared plus 5. So what we're going to do is that we say d over dx. Here in the exponent we have 3, so bring down 3, then x 3 minus 1, and then 4 minus 4. Then here in the exponent we have 2, so bring down 2, x 2 minus 1. Here we have a constant. How do we identify a constant? A constant is a number who don't have any x or y or any letter in general beside it. So 5 here is a constant, therefore, or in the rule, if it's a constant, it should, when derived, it should equal to 0. So plus 0. Here, then we just simplify this thing. So we have 3x, 3 minus 1, 2, then minus 4 times 2 equals to 8, x raised to 1. Okay, so this should be our final answer. Find the dy dx of y is equals to 5 x cubed minus 4x squared plus 3x minus 6. So d over dx, we have 5 here, then the exponent is 3, so 3x 3 minus 1 minus 4. Then we have the exponent 2, so 2, then x 2 minus 1 and plus 3. Then we have here exponent 1, so therefore 1 x 1 minus 1 minus 6, which is constant, so it should equal to 0. Then we simplify this. So 5 times 3, 5 times 3 is 15, x 3 minus 1 is 2, minus 4 times 2 is 8, x raised to 1, 2 minus 1 is 1, plus 3, x 1 minus 1 is equals to 0. Here, any number whose, let's say, has exponent 0 would equal to 1. Therefore, our final answer should be 15x squared minus 8x plus 3. On to our, let's say, third example, we have find the dy dx of y is equals to 4 all over 2x plus 1 cube. We could use the quotient rule here, but we could also use the power rule. How can we utilize the power rule here? The denominator, we just move it in the numerator. But how? How can we do that? So here, 4, 2x plus 1, then the exponent of the denominator would be negative. So negative 3. So what we're going to do here is that let's derive this one, dy dx. What will happen is 4. So here negative 3, so negative 3. If we derive, say, the outside, the outside, we should derive what is in the inside. So the inside is 2x plus 1. Its derivation would be, let's first copy here, 2x plus 1. The derivation of 2x plus 1, negative 3 minus 1, okay? Derivation of this would be just 2. Okay, so simplify. 4 times negative 3 is negative 12 times 2. Here's a 10, 2x plus 1 raised to negative 4. What would happen here is that multiply here, and then the negative 4, in order for it to become positive, we need to put it in the denominator at the bottom. So what here is negative 12 times 2 is negative 24 all over, let me rewrite this, put this here, negative 24 all over 2x plus 1 raised to 4. Then that should be our final answer. Y, find the dy dx of y, square root of 5 minus 6x. So what's the, let's say, derivative of this? So I want you to answer it all by yourself, then we would answer this together. So the derivative is that we know that square root would equal to 5 minus 6x equals to raised to 1/2. Therefore, then we could just derive it by doing this. Since the exponent is 1/2, then put the 1/2 here, and then 5 minus 6x 1/2 minus 1. And then since we derived the outside, we should derive the inside, which is 5. The derivation of this would be negative 6. So our final answer should look like or resemble like this one, 6x, so negative 1/2. 1/2 minus 1 is negative 1/2, negative 6. Therefore, my answer should look like negative 6. Wait, let me rewrite that. Rewrite that. So, negative 6 raised to all over 2, 5, negative 6x raised to 1/2, or square root. You could do anything like that. So then all we need to do is simplify this. Simplify. So negative 3 all over square root of 5 minus 6x. So this should be our final answer. So that's it. Bye-bye.